Day 5 of 365 was useful because it turned the common complexity classes from a list into a ranking I can actually feel. After Big O, time complexity, space complexity, and loop analysis, I now have enough context to compare the common growth patterns directly. The useful shift today was treating that ranking as a decision tool. It is not just a chart to memorize. It is a way to judge whether a solution can realistically survive the input sizes in front of me. The first big lesson was that the usual ladder matters a lot more in practice than it looks on paper. O1, O log n, O n log n, O n squared, O 2 to the power of n, and O n. Those symbols are close together in a line, but the growth gaps between them become massive very quickly. A linear scan and a quadratic nested loop may both look fine on a tiny test case, but once n grows, the difference becomes painful fast. Another useful shift was realizing that O1, O log n, and O n are usually the classes I want to see first. Constant time access, logarithmic search, and linear passes are the workhorses of scalable solutions. They do not guarantee the code is perfect, but they are often signs that the growth is at least under control. O n log n is also very respectable, especially when sorting or divide and conquer structure is genuinely part of the problem. That made O n log n easier to respect for the right reasons. It is not as small as linear, but it is often the realistic sweet spot when full ordering or structured decomposition is necessary. Efficient comparison sorting lives there for a reason. So if a solution lands at O n log n, the right question is not panic. The right question is whether that class is justified by the structure of the problem. The first real danger signal on the ladder is usually O n squared. That class is not always wrong, but it deserves immediate scrutiny. If I see quadratic growth, I want to ask whether hashing, sorting, two pointers, prefix sums, or another data structure could move the solution left on the ladder. Sometimes the answer is no because the input is small or the problem genuinely forces pairwise comparison. But O n squared should never pass without a design question. Another useful shift was how much more serious O 2 to the power of n and O n feel once I connect them to actual work. Exponential and factorial growth are not just a little worse than quadratic. They explode. These classes show up in subset generation, permutation generation, and exhaustive search. They are sometimes unavoidable, but they are almost never acceptable by accident. If I see one of them, I need to know exactly why the problem demands that kind of search. That is where input size makes the ranking practical. If n is small, a quadratic solution might be perfectly fine and easier to implement correctly. If n is large, even the difference between O n log n and O n squared becomes a real design boundary. Constraints turn the ranking from theory into a filter. They tell me which complexity classes are realistic before I sink too much time into coding the wrong approach. Another thing Day 5 clarified was that complexity classes are not moral categories. A smaller class is not automatically the best solution in every situation. Constant factors, implementation complexity, memory trade-offs, and constraints still matter. But the ranking is still powerful because it gives me a first pass on viability. It helps me reject obviously weak growth before I optimize the wrong thing. This also matters outside interviews. Production problems are often hidden inside the wrong growth class. Maybe a request path stayed quadratic when it should have become linear. Maybe a search remained linear when indexing could have made it logarithmic or constant. Maybe an exhaustive workflow is acceptable only because the input is intentionally tiny. The class ranking keeps those trade-offs visible. So my main takeaway from Day 5 was that common complexity classes should become a practical ladder in my head. Ask where the solution sits, ask what input sizes it can survive, and ask whether the class is justified by the problem or by a missing idea. If that becomes automatic, complexity analysis stops feeling academic and starts guiding real solution choices. That is what made today useful. The ranking finally turned into judgment.